Tonight is going to be the midterm study session, uh, group time for us. This is one of the two live lectures that we will have. So we're going to go over a bunch of problems. We're going to talk about the midterm exam, and we're just going to make sure that I answer any questions that you may have about it. And then we're gonna call it good tonight. I know that the quiz is still out tonight, so people are probably still trying to finish that up, and so we can probably talk about certain questions from those sections as well. So I'm just here to help tonight, and that's pretty much what it's gonna look like tonight. So first, let's just kind of talk about the midterm. So first of all, when is it? Let's just talk about all of the kind of the logistical things about it. So it's actually going to be next week, Tuesday. So let's see if I can write on here. Sometimes it comes out not so clear, but February 8th, which is Tuesday. So it actually opens February 8th, Tuesday at 12 noon or 12 midnight. And so that's a stroke of midnight. It's going to be open Tuesday, and then it closes Feb 9th. Which is that Wednesday, next week, Wednesday. And it's going to close at 11:59 p.m. So there's a 48-hour testing window. The midterm exam has to be taken within this time frame. So you really have 2 days to do the midterm. You get to pick the best time that works for you. But after Wednesday midnight, it's done. The midterm, we collect the results, we look at it, and you can no longer take it anymore. So it's pretty strict in terms of the deadline for this, okay? We don't extend the midterm. That's just not the way it goes. But the midterm is 25% of your grade. And we also know it covers from chapter 1 through chapter 5. And we've been quizzed on chapters 1, 2, 3, and 4. We haven't been quizzed on chapter 5, and we're not going to have a quiz on chapter 5. But parts of chapter 5 will appear on the midterm exam. I am going to give you some more kind of inside information about this, about the midterm exam, okay? This is what you can expect. 20 questions. The time allotted for everyone is 150 minutes. Okay, so that actually is an abundance of time. That breaks down to 2 hours and 30 minutes. So that's a gang of time. The time should be showing as you're taking the test. I like to have that type of feature selected so that you can kind of manage your time, you know, take coffee breaks, come back, work on it some more. But you do have to work on it in one sitting. If you do leave, you will have to notify me to unlock it. It may lock back. You may not be able to get back in. So you have to keep it up. But if it happens to lock out on you, it's no big deal. You just message me I'll be ready for your message and I will unlock it as soon as I can. And we'll just keep going until the closeout day on Wednesday. So that's that part. The next thing is, I'll kind of give you some more information about it, the sections that the test is going to be on. So I'm kind of going through it right now, and I will say from section 1.1, there will be 2 questions. And I do this to kind of give you an edge to help you in your preparation. In section 1.2, there will be 2 questions. Hopefully this comes out to 20. Right now that's 4. That accounts for 4 of them. It's already 20% of the test there. And then we have, it looks like 1 question from 1.3. For section 2.1, it's going to be just 1 question. Okay, so for 2.2, that's going to be 2 questions. Hit the pan tool. None for 2.3, and I don't even think 2.3 was even covered. 1 question for 2.4. And let's see. (3.1), just 1 question. So it's pretty spread out, as you can see. Three, two, 1 question. Three, four, 1 question, and 3, 5, 1 question. So I'm going to put it up here. And then that brings us to 4.1, 4.2. So then we got 4.1, 4.2. Both 1 question apiece. Let's see. All right, that brings us to 5.1. Looks like 2 questions from 5.1. Five, 2, 5, 3, 5, 4. So 1 apiece. Let's see if this should do it. 1 question there. 1 question there. Just trying to, and 1 question here. I'm going to tally all this up, see if it makes 20. So we got 2, 4, 5, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It looks like the chapter with the most questions would be 5, chapter 5, with 5 questions. Well, actually chapter 1 as well. Let's see if I can undo that. That was, are there any questions about these things, some of the technicalities of the final? It is online. And so that implies you can use your resources. We're not concerned about that. And I would say the best study guide for the midterm exam, which is happening a week from now, the best study guide is the practice midterm exam. Okay, so there was a question coming in about, oh yeah, that time. Yeah, I don't want time to be a factor. You know, time can, if you have the time to take it and sit there, then I'm willing to give you the time. We don't want any excuses either. So I try to give you tons of time. But you're right. I mean, I'm actually, I've been dealing with some weird stuff too. You know, it's on and off, and you just don't know. You just don't know how bad or how good. You know, it's weird right now what's happening with us physically, I think. And you know, a lot of people across the world are suffering in a lot of different ways, and a lot of it's unexpected. It's kind of sad, but you know, there's also a lot of good that's happening as well. And as far as how many attempts, the midterm exam is only 1 attempt. You only get 1 shot, and you do get your answer right away after you've submitted. But that being said, be sure to check your results, because I have in the past awarded partial credit where the computer didn't give partial credit for something that should not have been taken off so much. It could have been an error in terms of data entry, or a round off error, or just some other kind of technicality that where you demonstrated that you understood the question, but for whatever reason, you didn't get full credit for a question. You know, because there's 20 questions and each question is 5%, you know, a part of a question is significant. Half of a question, right? 50% of a question is like 3% of your grade. So you really have to, we're fighting for every point we can get on the test, as well as demonstrating your knowledge. But yes, to answer your question, there's only 1 attempt, and I don't think you wouldn't want to take it more than once, would you? So I guess the next thing we'll do is let's just spend some time looking over the practice midterm. Again, that's probably your best bet for preparation, and also the sections that I've listed out, like the ones that have 2 questions, you know, those would be sections that you want to make sure that you're ready for. 1.1, 1.2, 2.2, and 5.1. Those guys, I mean, that's already 2, 4, 6, 8 questions coming from those 4 sections alone. So that's kind of, and I will say, that you do get to use, the Stack Crunch is activated as well as the textbook. So sometimes you can select when you go into a test, you can select, help me solve this, or ask the instructor, or it may give you different options. I think the only options that will be available will be this Stack Crunch and the textbook. So yes, you can use the textbook. Hey, Cindy, yeah, I just answered that. Oh, okay, Cindy. You're saying how many attempts are allowed on the practice at midterm? It's unlimited. I might have put like 50 attempts or 99 attempts. I put some insane amount of number because I want to give you have the ability to go over the practice midterm a lot. So let's do that now. Let's jump into the practice midterm. And as far as using the textbook, yes, the textbook is not off limits. You feel free to use the textbook as you wish. And anything else that you can find that could help you. All right, so now let's jump into the practice midterm. It looks like it's here. It's kind of hard to access. I'm like, well, it's probably not even in a module, but it's off to the side. And then also you can go into assignments and you can get to it that way. Oh, well, okay, that's the practice final exam. Okay, but the practice midterm is here. Now it looks like it's in the wrong section. Both of those two should be in another section. Move this up real quick. All right, let me just kind of keep this organized a little bit. It doesn't matter because here's the thing. The practice midterms, the practice final, they do not get graded. It may look like you get a grade, it may give you a grade, but it will be deleted. So don't worry about getting graded on the practice midterm. A lot of people don't ever do it either. And then they freak out. They may do 1 or 2 questions and have like a 1% on it. And then it brings down their grade average. And then I just tell them this, next week, I'll delete them. I will delete the practice midterm. So there'll be no record of it. But you can get to the practice midterm by clicking on it right here. And I will say too, since we're here, in the discussion section, let me click on, I'll duplicate this. In the discussion section, I have put in helpful random homework videos. So sometimes you might search for something in here, it might not be there, and then all of a sudden I might create a problem that someone requested and put it in. Like the latest video that I made was from 3.2. Now, some of you guys probably did that a long time ago, but this is, and I try to be as instructive as I can. It's actually the solution. I actually go over the solution for the most part. This is a huge resource. There's a question here. This is a recent video, no longer than a week or 2 ago, I believe. Oh, no, not this one. And the empirical rule is recent. And then maybe some other ones that I made. But obviously we don't have many of these. So I'm always looking to make more videos to be more instructive so that for future classes, if it's a question that's really difficult, you should bring it to my attention and request that I make a video, and I will make a video and we'll put it in here, and that will help you get through your question. All right, you don't have to spend forever on it. And sometimes when you search for stuff online, you may not find it to the exact problem that you need. That's why it's important that we do it so that it's exactly your problem. And that's one of the issues with searching for stats. There's just so many versions of stats out there. So anyway, let's get back into the practice midterm exam, which is, it closes out, not that it's due, but the last day to access it is on the 7th, right before the real thing opens up. So there's 99 attempts, and I've given you 600 minutes, so that's actually 10 hours. Tons of time. There's 50 questions, all right? There's a lot of questions on this thing. It was designed that way just to give you more practice, okay? And if I'm not mistaken, you have options, or looks like the only options they're giving us is the textbook and StatCrunch. That's what it's going to be like on our test. You'll have these two options. And then you can submit test, resume for later, so on and so forth. So what we'll do is answer one of them, and then we're going to try to print out all the answers. So that I would actually would recommend that. A lot of people don't do that, but the truth is there's nothing wrong with doing that. It could assist you. It could help you prepare for the test better. Now, when you're actually taking the test, you kind of have to know what you're doing. So let's just go through this. And these are kind of weird because sometimes when you drag it, it doesn't fit in properly, and so you're probably pulling out your hair, you might have an answer, but it's just not going in. So sometimes you might have to zoom in or zoom out or something like that. So the first question says, provide a numerical measures of individuals. The measures can be added or subtracted and provide meaningful results. Yeah, okay, so provide numerical measures of individuals. I would go, I'm almost thinking of just data. But then if I put data in there, then I won't be able to use it again. I'm not, let's see, check in the chat if anybody has this one down already. Provide numerical measures of individuals. Let's see, let's make sure we got that one down. The next one is allow for classifications of individuals based on some attribute. So that's qualitative. The second one. The characteristics of individuals within a population. Information that describes characteristics of an individual. Has either a finite number of possible values or countable. So that's going to be discrete. All right, we're going to get there. Has an infinite number, but is not countable, so that's continuous. So I guess the key to dropping these in is you go a little bit below it, and once it's highlighted, it's okay to let it go. So you can't just let it go without knowing when it's selected or not. All right. So now it looks like I'm down to just 3. Information that describes characteristics of an individual. The characteristics of the individuals within the population. And then provide numerical measures of individuals. So I think the providing numerical measures is more, seems like we're talking about quantitative. Because something that can be quantified numerically would assign some numerical measurement to some individual. So I think I'm going to go with that one for right now. And that just leaves the last 2. A variable versus data. it seems like data is info, right? I mean, that's kind of one of the basic definitions of what data is that data is information. And so I kind of like this, but it's just more than this. It's not just something like this, right? And then here it says the characteristics of the individual within the population. Hmm. Well, wait a minute. Oh, characteristics of individual. So wait, maybe I have my quantitative and variables wrong. I'm going to put data in here, but something tells me that variable, the characteristics of the individuals within the population. No, now one thing we could do, because this question, sometimes you have to kind of identify the kind of question that you're on, right? This is definitely I believe a chapter 1 type of question. And sometimes what we could do is pull up our notes for chapter 1. So for example, our notes would be in the discussion section under classroom notes. And then we go to number 1, data collection. And the notes should give some definitions, like for example, data. It's data describes characteristics of an individual. What says it describes the characteristics of an individual? It's also referred to, the information referred to in definition is data. All right, so wait a minute. If they're saying the characteristics of, it describes the characteristics of an information, well, it looks like we have data in the right space, but what about variable, right? Parameters, good. Let's move on until we can see variables. So there's qualitative, categorical, and then also variables. Discrete and continuous. This is good. And as far as variable alone, they don't differentiate between qualitative and variables. But I guess what they're saying is that they do allow for classification. Okay, up top it says variables are characteristics of the individuals within a population. So we're going to go with here. We have our confirmation. Hit next. Now, one thing that just happened is that we didn't know whether or not we got it right or not. All right, that's kind of a problem. A blank is a person or object that is a member of the population being studied. This we could probably say a individual. All right, now we're going to stop it right here. We're going to hit submit test. And once we do, we're going to see that, okay, we actually got 2 questions right. We only answered 2 questions. I don't think we did the 3rd question yet, or did we? No, we never did the 3rd question. Let's get back there. Let's close this out. Let's see, how do we? All right, now 1 second here. I think when we went into a problem, we got lost a little bit, so hold on. Let's see here. So I might have to start the whole process over. Yeah, okay. That's not what we wanted to happen. So we'll do this real quick. Let's just um I don't want to do the whole problem again. We took such a long time to do that one. All right. Well, okay, I'll just randomly assign each one. We'll just do this quickly, just so that we can get back to where we were. Let's do this real quick. All right. So now I just answered. Now what we're going to do is submit the test, hit yes. And now what we're going to do is review the test. So we have the options to print the test with the correct answers. So this is kind of what we were looking for. We probably could have came in here in the beginning. So it's rendering. It's a little slow. And this is what we'll do. So we're going to print it, but I'm going to print it to my OneNote. All right, so now we have it. We have the test, and we also have solutions that can help us study this, right? So we're going to kind of go through it a lot faster now. Now that I've have it in my notebook, we can kind of go through it a little faster and work some of these problems out. Okay. And then if you have any questions from either the practice or even old homework questions or old quiz questions, you can throw them in the chat and we can discuss them as well. But you kind of saw the process. It's like, okay, there might be something that you're not 100% clear on, but at least if you know how to find it, and if you are organized enough and resourceful enough to be able to locate a document that could help you with it, like the textbook. But what I ended up doing was pulling up the workbook, the notes, and then from the notes, I was able to confirm a lot of what we thought the answers were going to be. All right, so we look at some of these. It's to determine whether the underlying numerical value is a parameter or a statistic. And keep in mind, parameter refers to population. And we also use the Greek letters. The Greek alphabet. And statistic refers to the sample. And we use English letters. So that's the difference between them. But remember, a sample is kind of like a miniature population. It behaves like a population, but that it's pulled from some. So in statistics, a lot of things are assumed to be a sample unless otherwise specified. But populations could be small as well, though, okay? There could be some finite populations or a population of only 5 members in it. I mean, it's possible. It just depends on how you define the group. But parameter is to population as statistic is to sample. So there's a connection between parameter and statistic that you should be aware of. Okay. And I mean, so if we go in knowing that, I mean, now it's just a matter of determine whether the underlying numerical value is a parameter or a statistic. In a phone survey of 100 random homes in a country, and so clearly that's not all of the homes in the country. It was random, and they said there was only 100 of them. And they say that 21% of the families had garages. So this value is actually a proportion. It's not a mean or median. It's a proportion, and this proportion is a statistic. And we know it's a statistic because the data set is from a sample. It's implied. Okay. Well, let's keep going. Weight. The question is weight qualitative or quantitative, right? And remember, we're talking quantitative. When you see that word quantitative, just think of numerical, something with a number, whereas qualitative, I think of like color or you know, it could be race, gender, color. It could be, you know, the number of car doors. I mean, you know, like let's say if cars were our data set. Let's just think about this for a second. If we have cars as our data set, the weight of a car or the length of the car or how fast the car can go, that's going to be all qualitative data values. But cars also have qualitative data values too. The color of the car, the make and model of the car, that's all data. And, you know, the number of doors, even though doors is kind of a numerical value, but when you're talking about whether it's a 2-door or 4-door, or, you know, or the number of seats, it's that value, even though it's numerical, it kind of does categorize the vehicle in a sense. It's kind of like the same thing with the numbers of jerseys and on the back of football players. You know, what do those numbers mean? Well, those numbers they're categorical values. They're not numerical. They don't have, you can't measure those numbers. Those numbers are attached to a name, and it's just easier to identify the players, to categorize them, or to, you know, locate their name. Again, names would be qualitative in that example. So let's move on. Oh, and then the answer to answer the question, is weight qualitative or quantitative? It is numerical. And not only that, it's continuous. You never know what the weight it really is. It's only as accurate as your instrument that's measuring you says it is. You know, you can always get more precise. Like you can step on a scale and it may say 175 pounds, you know, or 175.5. But in actuality, you could weigh 175.55 or 556. And we'll never know the exact value of your weight. It's only an approximation. And that goes with your age. Well, you know, your age is kind of, you know, you guys can think about that. Could we go, oh, there was a question that came in the chat. Could we go through and do questions 47 on the practice? Yes, absolutely. In fact, we probably can start from the bottom and work our way back up, because maybe the bottom questions are just The bottom questions are just more better. I don't know. So it looks like there's two parts to this question, and it says a test to determine whether a certain antibody is present is 99.9% effective. This means that the test will accurately hold on. This looks like a tough one. We got to warm up. Are we even warmed up for this? So it says, so since it's 99.9% effective, which is, I guess, pretty darn good, it means that the test will accurately come back negative if the antibody is not present 99.9% of the time. The probability of a test coming back positive when the antibody is not present, which is a false positive, is 0.001. Suppose the test is given to 5 randomly selected people who do not have the antibody. What is the probability that the test comes back negative for all 5 people? And then they summarize this. The probability of all 5 tests are negative. Well, the first thing I'm thinking of, well, wouldn't it just be the probability of all 5 people is going to be 0.999 times 0.999. And again, we're assuming the people are independent of each other. And there's probably random people at that, okay, 5 random people. So they're truly randomizers, not much bias. And then 0.999. Now, you can abbreviate this as 0.999 to the 5th power. All right, that's how you would put it in on your calculator. So that's what I'm going to do. I'm going to do 0.999. Because remember, 0.999 is 99.9%. So 0.999 is still 99.9% converted to a decimal. It's almost 1 whole. Raised to the 5th power. I get 0.995009. They say round to 4 places. So if I round it to 4 places, then it's 9950 or 995. So that's part A. And it checks out. Oh, okay, at least 1 positive. So then that it's just at least 1 positive. So here's the thing. The probability of at least 1 positive is equal to 1 minus the probability that they're all negative. So in other words, it's the answer from part A, but just we're subtracting it from 1. So 1 minus 0.995, which is 0.005. That's the thing about the at least 1. You know, think about it. What does at least 1 really mean? Sometimes that word throws people off, especially if English is not your first language. At least, when I hear the word at least, I'm thinking 1 or more. But sometimes when people hear the word at least, they think 1 or less, right? And so what I'm thinking is, if we're trying to calculate the probability of at least 1 positive, then we know in order to, the complement of that is that nobody's negative. So that's kind of how that one works. This is probably the best way to approach this kind of question. With the at least one positive one, you kind of want to do the complement. You want to figure out the probability of all of them are negative, and then just subtract that from one. So if they said at least one what if they said, what's the probability of at least one negative? Then we'd have to figure out the probability of all of them are positive and subtract that from one. Because they're complements of each other. It's one or both of these. It's either one or the other will happen. That's what we mean by complement. One of these will surely happen. You're either at least one will be positive, or all will be negative. One of those they're complements of each other. Together, it's surely will happen. If we were to add those two probabilities up, we will get one whole. One of them will happen for sure. Now, are there other ways to do it? Like if you want to break down at least one from a group of 5, I mean, you probably don't want to have to do that. I mean, first of all, the probability of someone is positive is 0.001. And out of a group of 5 people, like if you have 5 people, 1, 2, 3, 4, 5, and you're trying to calculate the probability if you were to randomly select 5 people and one of them have it out of the 5, what's your chances of that happening? There's going to be a lot of different combinations. So did that answer your question though? Was that helpful, Sarah? Okay. Yeah, 47, let's see, 48, 49. Okay, let's get into some probability stuff. Some of these would probably be helpful if you have the two-way table. Sometimes you got to just create the two-way table. Because when you have, let me see if we can find one with the table. To me, I've always liked doing the ones with the table. Now that's kind of like the table, but not really. This is a probabilities distribution table, or a probability model. Well, you're actually trying to figure out if it is or not. Remember, the rule is all of them must add up to 1, and none of the probabilities can be more than 1 or less than 0. They can't be negative. And then if that's the case, then yes, this is a probability model. But I'm trying to see if we can find a, yeah, like this is a two-way table. Construct a frequency marginal distribution. There's not going to be a problem like this on the test. We didn't really, I don't think there was many of this on the homework. I could be mistaken. But in order to do this, you need the formula. No, so 42 I wouldn't worry about. You problem like it. Here's another question that someone asked us the other day. How do you get the regression equation using StatCrunch? And I just told them I didn't even do it. I said to them, well, it was demonstrated in another video. And I don't know if that helped them or not. But if I had the time and if I could have showed them, I could show you now. In fact, there's a lot of ways to find the linear regression formula. Like for example, first of all, in order to get the regression formula, remember this is called a lot. It has a lot of names. It's called the least squares regression model. It's called the line of best fit. It has a lot of different names, but this book calls it the least squares regression model, because if you draw this line through the scatter plot, it will result in the least squares standard error. There's no other line. It's a unique value. There's no other line that you can draw through the data that will give you less error, because least squares is the error that they calculate. All right. So like, for example, just a kind of a quick, just so you can see what do we call it? A broad picture of what I'm talking about. If, let's say we have this graph and we have a bunch of dots, we have this scatter plot. All right, this looks like a positive correlation. Well, let's say this is the line of best fit. Right there. We know it's the line of best fit if it gives us the best least squares number, the lowest least squares number. Now, how do you calculate the least squares? You take the actual value and you subtract it from the estimated value. So anything on the line is an estimation. The actual value is here. This value, we square it so that it's positive, and we square this one so it's positive. We don't care. It might be negative, or we don't want to deal with negatives and positives, so we just square each one. And we add them all together. And the lowest, whichever line can give you the lowest number, is the line of best fit. It is the best predictor of the scatter plot. And that's the line that we use. So in order to calculate the line of best fit, you have to have two variables. You'll have to have an X and a Y. So you do it for all. So this one, the point here that's on the line, that one's not going to have any error. So that's really good. Then we do this one. We calculate the Y value. We do the Y value. And whatever the difference is, we just square it and add it to the sum, square it, add it to the sum, so on and so forth. We do it for each point. We're calculating the standard error. Now, how would you go about actually calculating this? Because it's actually, the formula is this gigantic, scary formula. It's very hard to do by hand. In fact, I would not recommend trying to do this by hand. I've never done it. Maybe once, but it's too complicated. You have to get the correlation coefficient and everything of the data sets. So anyway, let's pull up our calculator here. Now, in order for me to calculate the regression line, or the least squares regression line, we have to have two data. So right now I go into stat and I go into edit, and I don't have any data right now. All right, I'll just randomly select some numbers, okay? I'll do 5. And over here I'll do looks like it's going to be a nice strong correlation. All right. I can actually plot this and see if it looks good. We can create a scatter plot by going in the second stat plot. Turn on the first plot, and we're gonna select the scatter plot. It's already defaulted in. The next thing I have to do is hit second. The next thing I have to do is hit zoom first, not second, just zoom. Hey, no, zoom. Okay, and then go into number 9, zoom stat, number 9. Oh, it already plotted the line too. I didn't want that. That's different. Okay. There's my scatter plot. Nice positive correlation. I can hit trace and it will show me each point. We're going over. Now the question is, how do I get the line of best fit? Well, there's a bunch of different ways. There's two main ways to do it. You go to stat, you go over to calc, and then you choose number 4 or 8. They're the same. I'll just choose 4, not LN. It's already set up. All right, I'm actually going to store my frequency. Well, leave that blank. I could store my regression equation in Y1. Let me go to variables, choose Y variables, functions. I'll choose Y1. All right, let's hit calculate. There's my equation. It's Y equals A, which A happens to be 9.264, plus B, which B is negative 2.2. So you put it all together, it's Y equals 9.264x minus 2.2. That's the regression line. I could now go back to my graph. It's going to graph the line. That's the line of best fit. It looks like it fits the data pretty well. Because I stored that function in Y1, it did that. Whoa. All right. So that was one way to get the regression equation. There's some other ways too. I should turn on stat diagnostics. I think one way though, the book teaches you is to go into stat and then just go into run a test on it. And you're actually going to run one of the last tests that they give you. It's the regression t-test F. So the last thing is the ANOVA, analysis of variation. We don't have to do that in this class. L1 and L2, hit calc. We could store the regression equation in any variable we want, and then just hit calc. And it actually gave it to me. It's up top, Y equals A plus BX, but A is negative 2.2 and B is 9.2. They give us some other things. They give us the p-value, the critical, which we compare to the critical value. We have to know what the critical value is. They also give us the R and the R squared. The R is pretty positive. That looks really good. 0.7 is up there. It lets us know the direction and the magnitude, how strong it is, and whether or not it's positive or negative, positive slope or negative slope. So the R gives you two things. And remember, R goes from -1 to +1. The closer it is to 1 or -1, the stronger it is. And whether or not it's positive lets us know as one goes up, the other one goes up as well. They're both increasing. There's a positive direct relationship between the two variables. R squared is also the percent of variation that the model will explain. It's like a 50% shot, close to 50% of variation between the model of the Y values and the predicted Y values. And all you do to get the R squared is you just square R. It's literally R squared. Now, it could have been demonstrated in StatCrunch too, because the truth is that in StatCrunch, you don't have to mess around with data entry. You know, with data entry, you can make a lot of mistakes when you're transporting the data in. And there's actually a lot of other statistical packages where that's why Excel is so valuable. Because from Excel, if you convert it to a CSV, I mean, you can do all sort. I mean, there's all kinds of statistical software that can spit out anything statistical that we need. And a lot of these tools are free. Maybe one day I'll have to show that for those who are more interested in data analysis and you know, maybe you want to get into some computer science and you want to learn about how to manipulate the data in certain ways, then you can use Python or R. Those two languages can do a lot of it. And R is free as well. It's open source and it's free. It's pretty powerful stuff. And all right, let's get back to our test. I was looking for a two-way table type of problem, but I don't think we're going to find any. This one looks like you just need that formula. The formula is P of E or F is equal to P of E plus P of F minus P of E and F. But now the question is what's P of F? So we know P of E. P of E is 0.4. P of F, we'll just call it X. And they even give us P of E and F is 0.05. What about P or F? Well, that's 0.50. So what we have here is 0.5 equals 0.4 plus X minus 0.05. Well, let's combine these two like terms. 0.395, actually just yeah, I think it is going to be 395. Wait a minute. That's not 395. What is that? Let's actually subtract that. I don't know why I got confused there. We probably could just do this on our calculator too, but you're going to do 0.400, 0.050, subtract. Well, that's just 0. It's gone. Okay, of course. 0.35 and then plus X. And now when I subtract 0.35 from both sides, that's like 50. We're getting 15 equals X. And so X we define to be P of F. So P of F is 0.15, which matches what they got as well. So that's great. That matches. All right. Yep. So the plan wasn't to go over everything. I'm just going to go over a few questions that you may have had. And if there were any homework problems that you may have had that you wanted to look at, we can do that as well. So some of these are just, there's just way too much data to mess around with. Definitely would need some kind of statistical package for this. And StatCrunch will do a good job in plotting this out as well. Okay, so if there's no other questions, we're probably just going to wrap it up here. I think you'll be fine. And again, we can have another session as well. I'm willing to maybe have another session Monday night if there's a need. Monday night could be ideal.